Assalamualaikum and a very good day. My name is Nur Adlina Afrina, and today I will present to you the Gauss Theorem, or known as Divergence Theorem. This is our group member. Firstly, we have Tamarai Shelvi Anurban Ravindran, Muhammad Nizamuddin bin Hamzah, Tan Lizong, and Nur Adlina Afrina Miti Muhammad Kamil. Before we begin, I will expose to you what is Gauss Theorem, or another word of it is divergence theorem. Gauss theorem is a theorem that relates the surface integral over the boundary of a solid and a triple integral over the solid. As you can see, that is the formula and the triple integral of the Gauss theorem. Surface S is closed in the sense that it forms the complete boundary of the solid. That's why we have Gauss theorem to solve the question. Next, we will walk you through how to solve the question related to Gauss theorem. By the end of this video, I hope that you guys can understand the concept of Gauss theorem.
Hi everyone, this is the question for the divergence theorem and Gauss theorem. We will solve this question by using integration over of surface for vector f dot n dx is equal to triple integral over boundary of g divergence f dv. So for finding the divergence of f, we taking partial derivative for the vector f, and the answer we get is 3x squared plus 3y squared plus 2z. So for the triple integral over boundary of g divergence f dv is equal to this. And then for this question, we will use polar coordinate to determine the boundary. So we refer to the sketching, and then we can find that z is from 0 to 2, and for the radius is from 0 to 3. Thus is the theta. Theta is from 0 to 2 pi. After we find the value, we substitute the value into the equation, and we get from 0 to 2 pi is for d theta. And then from 0 to 3 is for dr. From 0 to 2 is for dz. After that, we convert 3x squared plus 3y squared into 3r squared. We multiply r into the bracket, and then we get 3r cubed plus 2zr dz dr d theta. Next, we proceed to integrate the z, and then we get 3r cubed z plus z squared r. Next, we substitute the value into z, and then we get 6r cubed plus 4r dr d theta. Next, we integrate the r, so we get 6 over 4 r power of 4 plus 2r squared, and then we substitute the value into the r, and then we get 279 over 2 d theta. Last, we integrate the theta, and then we get 279 over 2 theta, and then we substitute the value into the theta, and we get 279 pi. Therefore, the integration over of the surface for vector f dot n ds is equal to 279 pi.
Thus, for the 3D graph for the previous question, we decided to use GeoGebra that can be found easily in the internet. As we can see, we just need to insert the equation and radius from previous question. Then, we can get the graph as shown in the slide, which is a cylindrical. It has a radius with 3, which is similar with the question 1. Next, let's look into the Gauss law. So, Gauss law states that the total electrical flux passing through a closed surface is equal to an enclosed charge by that surface divided by electrical constant. Or, we can conclude it in the given formula which is shown in the slide. This formula states that integrate E electrical field dot dA surface area equals to Q enclosed, which is total charge within the given surface, and lastly divided it with the electrical constant.
Question 2. By using Gauss law, find the electrical field inside the cylinder given below. Given that the surface S equal to 8 meter squared and the length L equal to 4 meter. From the formula, firstly, we need to find Q enclosed. The formula for Q enclosed is integrate delta dV. The value for delta dV equal to Ks multiple S ds d theta dz. Next, we need to substitute the value region of S is 0 to 8. The value region of theta is 0 to 2 pi, and the value region for Z 0 to 4. After that, we need to solve the triple integral until we get the value for Q enclosed equal to 4096 theta K over 3. After that, we substitute the value for Q enclosed, mu naught and K into the main formula. The value for exponent not equal to 8.859 exponent negative 12, and the value for K equal to 8.99 exponent 9. We know that the formula for area equal to 2 pi ls, and we need to substitute the value for ls with 8 meter squared and 4 meter. Then we solve the formula until we get the modulus E is 2.166 exponent 22 Vm.